This video is about the empirical rule with normal distributions. And using the empirical rule with normal distributions, we first need to look at what is the empirical rule. So we have our normal distribution drawn. We have our mean represented here in the middle. And we have our standard deviations going on the positive side and going on the negative side. And what we have is some dotted lines drawn from 1 deviation away, at 2 deviations away, and at 3 deviations away. And here's the 3 rules that we have. 68% of all data in the distribution is within 1 standard deviation of the mean. So we're saying within 1 deviation of the mean, all this area represents 68% of all the data. If we go 2 deviations away, we're going to encompass 95% of all the data. So that's to this dotted line representing 2 standard deviations away from the mean. That will represent 95% of all the data. And you see that does encompass just about all of the big hump of our distribution. If we go 3 deviations away from the mean, that encompasses 99.7% of all our data in our distribution. And that is practically everything that's in the distribution. And that's why we talk about that we don't have to go more than 3 deviations away, otherwise it's going to be an outlier. That is usually the case, that outside of 3 deviations, it's very unusual for something to not be an outlier if it's beyond that. So, empirical rule gives us these 3 measurements to use to solve problems, knowing that within 1 deviation away, that's 68% of the data. 2 deviations includes 95% of the data, and 3 deviations away is 99.7% of the data. So let's look at an example problem of how we would use that. So if we had female adults that had an average age of 30 and a standard deviation of 5, we want to find the following questions. The first thing that we would do is to draw a normal distribution and kind of lay out for this information in that normal distribution. So our mean is at 30. A standard deviation of 5 means we would have 35, 40, and 45. Going to the left, we would subtract it. So we would have 25, 20, and 15. So our first question is what percent is between 25 and 35? Well, here's 25 and here's 35. Both of those are within 1 standard deviation from the mean. So following our rule for empirical information, that means that that is 68% of all the people in the survey are within that range. A second question might be, what percent is greater than 35? Now, 35 is one standard deviation above the mean. So that means that we want to know how much is above that. So we have to do a little bit of finagling here. If this point and beyond, well, this point is 50%, and then this point is half of that 68%, so that makes that 34. So that's 50 plus 34, which makes 84, and everything would be 100%. So 100 minus 84% means that that would be 16% left, and that would be the answer to our problem. So we have to use the empirical rule information, but we may have to manipulate it a little bit in order to actually find answers to certain kinds of questions. A third question might be, what's between, or what percent is between 20 and 35? All right, 20 is 2 deviations below, and the 35 is only 1. So we know that that amount from here to here is 34. All right, and then from here to here is 34, and then from here to here is how much more? Well, according to the empirical rule, half of that 95 would be 47 and a half, I believe. So we could say 47 and a half, and then add those two amounts together, and we get 81.5, I believe. And that gives you an idea of some of the types of questions that you might see used with the empirical rule when we utilize it in particular problems. Now, I want to summarize what we've been going over with our normal distributions and empirical rules. To be sure that we have some key points down about this information. First of all, when we look at a normal distribution, we need to remember that it is symmetric about the mean. That means that the mean divides the data up into 2 equal parts, 50% on one side of the mean, 50% on the other side. A second characteristic is that your mean, your median, and your mode are all equal when you have a normal distribution. They all fall there together. You have one peak. You don't have multiple peaks, and it's all there in the middle where the mean, median, and the mode all meet. A third characteristic is that you have points of inflection. And those points of inflection are at one standard deviation and that is on the curve, and it's the change from being concave up to concave down. That's what a point of inflection means. We know that normal distribution also is known as the area under the curve. We know that the mean divides the area into two parts. So it is 1/2 on the left and 1/2 on the right. We know that the graph increases without bound. In other words, that means that it goes on forever and ever, but it will never touch the axis. And that also means on the left side as well, it decreases. We know it is also known as a density curve. And a probability curve. So these are just some points to summarize some information about a normal distribution and being sure that we do know these characteristics of a normal distribution.